Today we will be interpreting parabolas. Let's read question 6 together. The sketch below represents the graph of two parabolas f and g, where f of x is equals to half x squared minus 8. The turning point of g is 2, c is 2 and 9, and the y-intercept of g is a, 0 and 5. Those are critical points, important. B and D are the x-intercepts of f and g respectively. Right. So those are what the graphs look like. Let's go to number 6.1. It says prove or show that g of x is equals to negative x squared plus 4 of x plus 5. Let's see what we have, what information we have on the graph. Oh, it turns out that we have a turning point at C with coordinates x and 9. So I think the appropriate formula to use would be the turning point general formula, sometimes referred to as the vertex formula, which is given as follows: g of x is equals to, I'm writing it in general form first, a x minus h the whole squared plus k. K is equals to, g of x is equals to a x minus h is the x coordinate of c plus 9. That k isn't supposed to be squared. Let me remove that too. Sorry for that. Right. So the goal is to look for a, but we have another point a, and we can use the coordinates of a, capital A, the point, to find the coefficient a. Right. So it's just a matter of substitution. When the output is 5, when g of x is 5, the output a is equals to the input is 0 minus 2 to the whole squared plus 9. So now we just make a the subject of the formula. 5 is equals to a minus 2 to the whole squared plus 4. Take 4 to the other side. Take 9 to the other side. I beg your pardon. Right. So a, divide both sides by 4, right? 4 and 4 cancel, 4 and 4 cancel, minus a is equals to negative 1. So now we can back substitute that into the above general equation. Let's do that. So therefore g of x should be equals to negative 1 x minus 2 to the whole squared plus 9 minus 1 x minus x squared minus 4x plus 4. If you expand x minus 2 squared, that's what you get. Use distributive property, multiply negative 1 by everything within the brackets, minus 4x plus 4 plus sorry, let me correct that. That was supposed to be plus 4 and that was supposed to be minus 4 plus 9. Add and subtract like terms gives us minus x squared plus 4x plus positive 5 minus 4 plus 9, hold on, 4x minus 4 plus 9, right? And therefore minus x squared plus 4x minus 4 plus 9 is negative 5, and that is what we have there. So very important, right? So let's have a look at 6.2, right? Let's have a look at 6.2. It says find the average gradient G between 2 points A and C. And take note, the coordinates of those points are given. So basically, we need to find the average gradient, the line that joins the 2 points. So draw a line. Grade 11s, don't be hesitant. Do as much rough work as possible. Draw the line, join the dots, show change in Y and change in X, right? And we are given the coordinates, right? Change in X and change in Y. We know change in Y, change in X we are given, so we can use the gradient formula and just substitute those given points. So therefore, the gradient of the line AB, represented by AC rather, is equals to, let me rather use the A and C, YA minus YC over XA minus XC, right? So just a matter of substitution. 5 minus 9 divided by 0 minus 2. This is equals to -4 over -2. So this gives us +2. So the gradient is +2. And we can see the slope. So definitely that seems about right. So let's move along to 6.3, right? So calculate the length of BD. So the length is that green line B that joins the point B and D. So quite clearly it's just a matter of finding the coordinates for B and the coordinates for D, and those are the x-intercepts for the respective graphs. Let's start with the function f of x. Let's find the x-intercepts for f of x. So I'm going to write it as follows. For the function f, if we let y, to find the x-intercept, right? If you let y equals 0, then you plug y with 0, then we can get the x-intercept. So half x squared minus 8, take 8 to the other side, becomes positive. Half x squared, multiply left and right by positive 2 to eliminate the fraction. So 8 times 3 is 16, x squared. To get rid of the square, take the square root on both sides. Square root. Don't forget to put plus minus. Very important. A lot of students forget to put that plus minus. Therefore, x square root and square cancel out. X should be plus minus 4, right? Plus minus 4. So that already tells us that already gives us the coordinates for B, which is -4 and 0. X is -4 and y is 0, right? So the same can be done for G. The same thing can be done. So for the function g of x, to get the x-intercepts, we substitute y with 0, right? Let's plug that 0 in. So let's write the formula. Therefore, 0 should be equals to, there's the general equation, there's the equation there under for g of x. So it's equals to -x squared plus 4 of x minus 5, right? Therefore, multiply both sides by -1. It's always better to have a positive to find the solutions, So therefore it's easy to find the solutions. So therefore 0 should be equals to x close brackets. Let's see, to get positive 5, I think negative 5 and positive 1 could work, definitely. Negative 5 and positive 1, and yeah, those work. So therefore x should give you negative. You can use the distributive property to see if those solutions are valid. Minus 1, or x should be equals to positive 5. So quite evidently x, the coordinates of D are positive 5 and 0. Right, so now it's easy to find the distance. The distance between the origin and D is 5 units. That's quite clear, 5 units. And the distance between the origin and B, remember 4 units, to these 4 units to the left is 4 units. So the sum of the two, the length, in other words, the length of BD is equals to 5 plus 4, which is equals to 9. Perfect. Lovely. Lovely. Right, let's have a look at 6.4.1, for which values of x is f of x greater than or equals to 0. So we're looking for all the x values for which f of x is above the x-axis and greater than or equals to 0. So let's look at the regions. Let's look at the places where f is a positive, f is greater than or equals to 0. Let's just use green. I'm going to use green to highlight the areas. So it's this area here. We can see f is just getting for all x values in that region, f is above the x-axis. F is positive or greater than 0. So x should be less than or equals to negative 4. Okay, let me write this more clearly. X should be strictly smaller than or equals to negative 4, right? But there's another region for which f is positive, strictly positive, or equals to 0, and this here, starting from here, is the region. We can see in this area f of x stays positive. So f of x is positive from 4, and those coordinates are 4 and 0, right? So x must be greater than or equals to positive 4. So those are the only two regions for which f of x is strictly greater than or equals to 0, right? So let's just write it. So for f of x to be greater than or equals to 0, it means that x should be greater than or equals to positive 4, and x should be greater than or equals to, hold on, x should be greater than or equals to negative 4. No, sorry, x should be, let's check, x should be less than or equals to 4, and negative 4, and x should be greater than or equals to positive 4, right? Okay. Let's move on to the next question, 6.4.2. right? So f and g are both strictly increasing. So let's try and find that region for which both functions are increasing, right? And remember, turning points are not where functions increase. So whatever coordinate is I, the turning points for both functions are not included, right? So let's look. So if g is increasing between those points A and C, right? Not exactly by C, because C is a turning point, but it approaches C. And it seems like this is the region, because G increases from the y-intercept to the turning point, approaching the turning point where C is. So in that region, both functions are increasing. It's quite clear. They're both going up. So x has to be greater than 0 and x has to be smaller than 2. Guys, please consider subscribing to my channel. I regularly post videos, and if you have any questions, please drop a question in the comment section. Thanks for watching.